Hello Mathemaniacs, I'm the Math Edumacator. Today we're going to be talking about arithmetic using rational numbers, or fractions. Before we get started, I want to go over two things. The first is, there's always more than one way to write a fraction. Let's say I have this piece of paper. Now, this piece of paper is folded in half. So, if I were to tear it across this crease, then I would have two pieces that were the same size, so that would be a fraction. So this piece of paper would be 1/2, because there's one piece, and two pieces this size make a whole sheet of paper. However, suppose I folded it again and kept both pieces this time. Now I have two pieces, and if I had four pieces this size, that would be equivalent to the entire piece of paper. So that would be 2/4, or 2/4. But it's the same amount of paper that I had for 1/2. Now if I did the same thing and cut both of these in half, how many pieces would I have? So now I have 4 pieces, and 8 pieces this size would make a whole sheet of paper. So this would be 4/8, or 4/8. But again, it's still the same amount of paper. So all of these fractions are used to describe the same amount of paper. These are what we call equivalent fractions. 1/2, 2/4, and 4/8 are all different ways to describe the same quantity. Numerically, we can tell if two fractions are equivalent by looking at the numerator and the denominator. I can multiply both the numerator and the denominator by the same number, and whatever I get will be an equivalent fraction. So 1/2, 1 times 4 is 4, and 2 times 4 is 8. 1/2, 4/8. And the same is true in reverse. If I have a fraction and I can divide both the numerator and the denominator by the same number, then what I'll get is an equivalent fraction. 4/8. 4 divided by 4 is 1. 8 divided by 4 is 2. 4/8, 1/2. Now if I keep dividing and keep dividing until I can't divide the numerator and the denominator by the same number anymore, except for 1, then that's what we call a reduced fraction. While there are many ways to write a fraction, every fraction quantity has one reduced fraction. And when you're writing a fraction, using its reduced form is always the most proper way. So, the second thing is that it's important to note that any number divided by itself is just 1. So anytime you see a fraction like 5/5, 6/6, 100/100, 10 million over 10 million, these are all equals of 1. Now, let's talk about using arithmetic with fractions. Let's start with multiplication, since that's the easiest one. Whenever you have your two fractions and you're multiplying them, you multiply the two numerators and the two denominators. The product of your two numerators will be your new numerator, and the product of your two denominators will be your denominator. Pretty simple. We can actually see this demonstrated if we use a reciprocal. The last time we talked about fractions, I mentioned that any number times its reciprocal is always 1. So let's take a look at that here. Here you have 2/5 and 5/2. If you multiply them together, 2 times 5 is 10, and 5 times 2 is also 10. So that leaves us with 10/10. Well, any number over itself is just 1. So, hence, our number times its reciprocal is just 1. What about dividing fractions? Well, here's how it works. Dividing by a number is like multiplying by the reciprocal of that number. So let's take something like our previous problem, except this time it's 2/5 divided by 5/2. Now, in this case, all we have to do is take the reciprocal of our second number, which would be just 2/5. Then our division becomes multiplication. So now we have 2/5 times 2/5. Well, we know how to multiply. We simply multiply our numerators. 2 times 2 is 4. And we multiply our denominators. 5 times 5 is 25. So our new result is 4/25. I do want to note here real quick one thing about number sense. Whenever we use whole numbers, or numbers greater than 1, When we multiply, we end up with a number bigger than what we started with. And when we divide, we end up with something smaller than what we started with. If we use fractions that are less than 1, those results are reversed. If I multiply a number by a fraction like 1/2, my result will be less than that original number. And if I were to divide by a number like 1/2, my result would be more than that original number. So 1 is our important threshold when it comes to multiplying and dividing. Anything between 0 and 1 is going to behave the opposite of something that's greater than 1. Now, let's talk about adding or subtracting with fractions. This is a little bit trickier for most people. Now, to illustrate how this works, let's take something like 4/8 plus 3/8. What would that look like? So here I've got the 4/8 I had earlier, and over here I've got 3/8. So it's the same size pieces, just 3 of them. What action do I use to add physical objects? Well, I just put them together. Now I have 7 pieces all the same size. Now each of these pieces is 1/8 of a whole sheet of paper. So that means that if I have 7 of them, I have 7/8. So if I look at the numbers here, what I did was I only added the numerators, and I left the denominators alone. Remember, the denominator only tells us how big or small our pieces are. It doesn't say anything about how many pieces we have, like the numerator does. So, because the denominator talks about size rather than quantity, we only add the numerators together. However, for this to work, it's very important that our denominators are the same. In this problem, it's fine, because our numbers are the same. But what if we had something different, like 1/2 plus 2/8? So here are my 2/8, and this would be my 1/2. If I'm adding them, I can just put them together. So we have 3 pieces here. However, the problem is that the pieces aren't all the same size. Since these pieces are different sizes, we couldn't use the same denominator to talk about all 3 of them. And so we can't come up with a fraction like that. So what do we do if we need to add, but we have denominators that are different? Well, we use equivalent fractions. From earlier, I remember that 1/2 is the same as 4/8. And what that means is I can use 4/8 instead of 1/2 in my problem. If I do that, then instead of 1/2 and 2/8, I have 4/8 and 2/8. If I put those together, all my pieces are 1/8, and I have 6 of them. So that would be 6/8. And I could reduce that by dividing both 6 and 8 by 2, giving me 3/4. So, ladies and gentlemen, that's why the common denominator is so important. Because without it, you'd be trying to come up with how much of something you have by using different size pieces. This is really difficult. But if all of your pieces are the same size, it becomes a piece of cake. Or a piece of pie. So we can use equivalent fractions to add fractions with unlike denominators. But how do we find those equivalent fractions? Suppose we have a case like the one we just did, where we only had to find one equivalent fraction. This is because one of our denominators is actually a multiple of the other. In this case, 8 being a multiple of 2. We can multiply 2 by 4 in order to get 8. So that changes our denominator. Now, in order to keep our fraction equivalent, we have to multiply the numerator by the same number that we multiplied the denominator by. So 2 times 4 is 8, and 1 times 4 is 4. Hence, 1/2 becomes 4/8. Now sometimes this won't be the case. Suppose that you had 4/5 plus 1/6. 6 is not a multiple of 5, and 5 is not a multiple of 6. What this means is that we're actually going to have to find equivalent fractions for both of these. Now, one of the ways that you can always find a common denominator is if you multiplied each denominator by the other one. So in this case, you'd end up with 30. 5 times 6 is 30, and 6 times 5 is 30. So I multiply my first fraction by 6/6, which gives me 24/30, and I multiply my second fraction by 5/5, which gives me 5/30. 24 plus 5 is 29. That gives me 29/30. The advantage of multiplying the denominators is that it always works. In some cases, you might be able to find a denominator that's less than the number you get if you multiply them together, but it's not guaranteed all the time. So hopefully most of you learned something today about operations with fractions. Using this, combined with operating with negative numbers from last week, that gives us some really powerful tools for lots of arithmetic. And that's all the time we have for this week's video. Next week, I'll be on vacation, so we might have to take a short break before... Hey, John. Huh? I can host the show while you're gone. Oh, yeah, sure, you can do the video next week. Sounds like fun. I'll make sure to get the video out on time. Awesome. Well, Billy's going to be doing the video next week. And what did you want to do it on? I wanted to talk a little bit about PEMDAS. Order of operations. See you next time. Thank you for watching. If you enjoyed this week's video, please like, comment below, and share the link. If you want to see more, subscribe to our official YouTube channel and follow us on Twitter at Edumacator.